And welcome back, students. As we continue our discussion of linked lists, today we're going to look at a generic linked list example, and we're also going to discuss the application of the equals method. So as we look at our example here, you'll notice that we have another linked list here. We have linked list 3 bracket t, shows a generic linked list with type parameter t for the type of data stored in a node. Now, this generic linked list has the same methods that we pretty much have seen before, coded in pretty much the exact same way as our previous linked list, but we're using a type parameter for the type of data in the nodes. So the generic linked list demo, when we look at that, will contain a demo program for our generic linked list that uses the class entry, therefore, as the type plugged in for the type parameter t. Now, note that if you want multiple pieces of data in each node, you simply will use a class type for the multiple instance variables and plug in this class for the type parameter t. All right, so with that being said, let's discuss a quick pitfall, which is an easy one that you could do, which is using node instead of node bracket t. So this pitfall is best explained by example using the linked list 3 t class. However, the lesson that we're trying to get across here applies pretty much to any generic link structure with a node inner class. The type parameter need not be t, and the node class name need not be named node, but for simplicity, we're going to use t and node. So when you're defining linked list 3 t class, the type for a node is node t. It is not simply just node. However, it's easy to forget the type specification t and write node instead of node t. So it's very easy to forget that, and you're like, oh, well, it's just node, but it's actually node t. Now, if you omit the node part t with the angle brackets in there, you may or you may not get a compile error message depending upon the other details of your code. So it's very possible you could just put node in there and it won't give you any errors. Now, if you do get a compile error message, it's likely seeing something that's really strange and out of place. Now, the problem is that node, in the terms of context of what we're talking about here, actually will mean something totally different. For the purpose of our course, we don't going to have time to stop and explain what node means. All right, it's something different, but the best way we can wait for you in a kind of a TLDR setting is that it's something like a node with a data type called object rather than data type t. Now, your only defense against this pitfall is pretty much to be very careful. If you do get kind of a bewildered compile error message, first thing you want to do, look for that missing angle t. Sometimes a compile error warning message can be helpful when you make a mistake, but remember, sometimes it will not show up. So it's best to kind of use your own judgment on this. Now, if you get a warning that mentions a typecast from node to node t, obviously the easiest thing to do is just look for an omitted bracket t. Finally, we should know that sometimes your code will compile and run correctly, as I've already mentioned, if you omit the t from node t. So obviously you got to watch out for that error right there. Now, with that being said, that's a kind of we're going to come back and I'll look at the generics in a second, but I want to quickly talk about the equals method for linked lists. The linked lists that we have looked at previously, linked list 1 and linked list 2, don't have an equals method in them. All right. Now, the reason why we omitted the equals method is pretty much just to keep those first two examples simple and not to detract from the main message, but we were trying to convey how to show how to construct a linked list class. But because it's a class, it should normally have an equals method. Remember, kind of the two methods that we literally kind of try to keep into a program, if you remember from programming 2, are our toString and our equals methods. Those are kind of the two golden methods you always want to have in a class. Now, there is more than one approach to defining a reasonable equals method for that of a linked list. So the first way is that you can have two linked lists are equal if they contain the same data entries, so possibly they could be ordered differently. And the other way is the two linked lists are equal if they contain the same data entries in the same order. That is, the data in the first node of the calling object equals the data in the first node of the other linked list. The data of the two second nodes are equal, and so on and so forth. So node 1 and node 1, they're equal. Node 2, etc., so on. Now, it's not true that one of these is the correct approach to defining an equals method and the other is incorrect. Both of these are legitimate ways to approach how to make your equals method. Now, in different situations, you might want the different definitions of equals. However, the most common way, and it's the way that we're going to show you, is to define equals for a linked list is using approach 2. Definition of equals that follows approach 2 and that can be added to the class linked list 2 is shown in the class materials within the linked list 3 bracket T class. The generic linked list also contains an equals method, as I kind of mentioned, which is approach 2, and I'll point out that equals method when we actually look at the program itself. Now note that when we define equals for our linked list with type parameter T, we trust that the programmer who wrote the definition for the type plugged in for T. What we're doing is we're assuming that the program has redefined the equals method, so it provides a reasonable test for equality. Now, situations such as this are the reason why it's important to always include an equals method in the classes that you define. All right, so that wraps up kind of the notes portion, so let's hop over to clips and actually take a look at our methods here. So here I have linked list 3, right? And in linked list 3, of course, I have a node inner class again. So that's what we talked about before. But of course, you'll notice that with this one, we are now using a generic approach. So that's why we have the type parameter T. All right, so it's very similar to what we've seen before. I do want to bring us all the way down here, though, because we do have right here a equals method. So this is what you would want to use. So you can see we have a equals object, other object. And then we look to see if it's null, return false. Otherwise, if it's not a other object, return false. Then fall in the else case. All right, we're going to say, hey, I'm going to set this other list equal to the other object. If the sizes are not the same, so that's a quick and easy way to tell if the sizes aren't the same, return false. If you have a list of size 3 and a list of size 5, obviously we know they're not the same. Otherwise, what we're going to do is we're going to set the heads pretty much at the starting position. And then what we're going to do is we're going through each element within that list, and we're going to compare it to the other corresponding element. And of course, then we just update the position. All right, and of course, if there's no mismatch, we have a return true, but if at any point there is something that is not the same, we're going to return false. All right. Now we also have this entry program right here, which we'll need for a demo. So entry, of course, you can see is simply just another class. Here's another equals method that's very similar to what we've seen. We have our toString method, and of course, entry is just simply going to take in a string and a int. And so when we look at our demo here, so this, of course, entry is the class type that we're going to be using for a generic class. So we have public class generic linked list demo, and of course, here's our main method. We have linked list 3 entry list, new linked list entry. So entry is the class type, all right? Because before we've seen things like string, but here is a unique class called entry. And of course, we are simply just adding elements to that list. So here I'm taking a string and a number, string and a number, string and a number, adding it to each of those. And then of course, I have a print line statement which simply just returns the size of that. And of course, list.size is not, of course, an entry because entry is a type for linked list. So I can just call it list.size. And then I just output that list and then end a list. So when we actually run this, all right, list has 3 nodes. That's this right here. And then we have cantaloupe 3, bananas 2, apples 1, end of list. All right, and that's going to wrap up this lesson, folks. Hopefully that helps give you some ideas of how to use linked lists and also how to incorporate some generics in there. With that being said, I will see you next time.